Today I'm going to be talking about analyzing conditional statements. So let's see what a conditional statement actually is. We usually write a conditional statement in if-then format. And if we look at the very top, we see a symbol. We have a P, then an arrow, and then a Q. Okay, and this is the symbol, the shortcut of writing if-then format. So if we have a statement, if something, then something, the if portion is the hypothesis, and that's our P. And then the then is our conclusion, which is our Q. And we're going to use these symbols to help us write new statements. So let's just make up a statement and say, if it is raining, then the ground is wet. So our P, or our hypothesis, is if it is raining, and our conclusion, our Q, is then the ground is wet. So let's practice writing if-then statements. So we're going to take our statement and we're going to write it into if-then form. So the first one says, all birds have feathers. And if we take a look at this sentence, we're going to kind of break it up into two pieces. Our first part is all birds, and the second part is have feathers. So we kind of have a hypothesis and a conclusion already. We can add a few words in here to make it actually sound good when we put it into if-then form. So we know a bird is an animal, so we can say if an animal is a bird, then it has feathers. So we have a hypothesis and a conclusion, and our conditional statement is now in if-then form. Okay, so let's look at our next one. And the next one is a little tricky because they've actually already given us our hypothesis. If we see the word if, that tells us the statement right after it is our hypothesis. So in this special case, we already know the hypothesis, and it's the second statement. So we can say, if two angles are a linear pair, then they are supplementary. Right, and that's a special case. Now for the next one, we're going to do the same as we did for the first one. We're going to split it into two different pieces. And how we're going to do this is our first piece is tourists at the Alamo, and our second piece is are in Texas. So we can write a conditional statement in if-then form. And let's say if tourists are at the Alamo, then they are in Texas. Now let's look at our very last one. Let's break it into two pieces. The first one is all 90-degree angles, and the last piece is our right angles. So let's put this into if-then form. If an angle is 90 degrees, then it is a right angle. Okay. So that's how you can take a statement and write it into a conditional statement in if-then form. Now let's take a look at taking our conditional statements and writing the converse. And if we take a look at the top, our symbols has switched. Our Q, then, if we take Q, then P. So we're writing our hypothesis second and our conclusion first. So the converse always switches them. We have an example of our conditional statement. So we have if measure of angle A is 99 degrees, which is our P, our hypothesis, then angle A is obtuse. That's our Q. Now if we write the converse, we flip it and we start with Q. If angle A is obtuse, then the measure of angle A is 99. which is our hypothesis. So all we do is we flip the hypothesis and the conclusion, and we've got our converse. So let's try this out, okay? It says, if you are a guitar player, which is our hypothesis, then you are a musician, which is our conclusion. So to write the converse, we're just going to flip that. If you are a musician, then you are a guitar player. Now, if you notice, this statement is not true because you can be a musician and not play guitar. You can play a different instrument. The converse doesn't always have to be true. Sometimes they can be false, and in this case, it is. So let's try this again. Our hypothesis for this, if a dog is a Great Dane, our conclusion is, then it is large. So we're going to flip it to do the converse. So we say, if a dog is large, then it is a Great Dane. Let's do the very last one. Our hypothesis is if a polygon is equilateral. Our conclusion is then the polygon is regular. So we're going to flip it to the converse and say if a polygon is regular, then it is equilateral. All right, so that is writing our converse. And now our next piece is negating statements, writing a negation. And if we look at our symbol up here, if I want you to negate a statement, I'm going to put a squiggly mark right in front of it. So that tells us we have to negate a statement. So if we take something like the ball is red, to negate it, it's very simple. We just say the ball is not red. And we can go the other way. This one, the next one, says the cat is not black. So to negate it, we say the cat is black. So we can go either way to negate a sentence. Okay? So let's put all of our pieces together and start writing these different statements. Okay? So the first thing that says let P, which is our hypothesis, be you are a guitar player. And then let Q, which is our conclusion, be you are a musician. And we're going to use our P's and Q's and our symbols to help us write these statements. Okay, so we're going to write each statement in words. Then we're going to decide if that statement is true or false. So A says write a conditional statement, and it shows a symbol if P then Q. So we know to write it in if then format. So we're going to say if you are a guitar player, then you are a musician. Okay, and we're going to look at this. Is this true or false? Well, if you're a guitar player, then yes, you are a musician. You play music. So that's true. Now we're going to write the converse, and it shows us to switch the P and the Q. The Q goes first, then the P. So we're going to say, if you are a musician, then you are a guitar player. And as we've seen this before, this is false because you can be a musician and play a different instrument. Now the next one is the inverse. We haven't seen this word, but we actually can look at the symbols and it tells us to write if P then Q, and if we look at the squiggly marks, it tells us to negate both of those. So we're going to start off with P and we're going to negate that statement. If you are not a guitar player, comma, and then we're going to negate the second statement, then you are not a musician. And let's look at that statement if it's true or false. Okay, if you're not a guitar player, then you're not a musician. Well, that's false, because you could play piano and you are a musician, so that's false. And the very last one is called a contrapositive. And if you notice, they flipped the Q and the P, and they've also negated it. So we're going to start with a Q and negate it. If you are not a musician, then you are not a guitar player. And if you're not a musician, you don't play anything, any type of instrument at all, so that is true. So those are all 4 of our different types of statements, and we really can use our symbols to help guide us write these statements. And our very last piece is a biconditional statement. When we have a conditional statement that is true and its converse is true, then we can write a biconditional statement, which includes if and only if. And a biconditional statement only applies to definitions, because definitions are the only statements that are true with conditional and its converse. So if we look at this first statement, it says if 2 lines intersect to form a right angle, then they are perpendicular lines. That is true. Let's look at the converse. If 2 perpendicular lines intersect, then they form a right angle. That's true as well. So we can write a biconditional statement. And we're talking about perpendicular lines here. So we're always going to start with the word that we're defining. So we're going to say 2 lines are perpendicular if and only if they intersect to form a right angle. And let's practice it with the second one. If we read this, it says if an angle is a right angle, then its measure is 90 degrees. Okay, so we're talking about a right angle here. We're talking about the definition of a right angle, so we can start off with that. An angle is a right angle if and only if its measure is 90 degrees. And that's your biconditional statement for your definitions. You must have if and only if in the middle.